Okay, so yesterday we talked about finding samples, how to gather the data, and making sure that the data is what we call representative of the population. Little bit on how to choose the samples, random sampling and stuff like that, and just general vocabulary and organizing the data in graphs so that it's visual and easier to draw some conclusions from. We started yesterday having tables in front of us, and we pulled the data out of those tables to create a graph. So today I want to start out with taking a step back. If we have raw data, where do those tables come from? They're called frequency tables. And all a frequency table is it's breaking our raw data down into groups of some sort. So you call it a group, or sometimes called a class. Sometimes we put a name of whatever it is we're putting there. And then we give a frequency. In other words, how often does our data fall into that group? Most of what we did yesterday for our graphs and stuff was what we called categorical data. Remember, categorical data refers to the type of question that's being asked and what the answer to that question is. If the answer to that question puts you into a category, it's considered categorical data. We talked about favorite color. We gave you three options, or which of these three colors would you prefer? And we gave you three options. And whichever one you chose put you in a category of one of those colors. If you're looking at a political survey, which candidate would you vote for? Well, that puts you into a category. All yes or no questions are categorical, because answering yes or no puts you in the pro or con categories. So let's go back now and look at raw data and how we would organize it for categorical data. And let's go back to that question of which of these three colors do you prefer? And we're going to stick with the red, blue, and green again. A little bit. Okay, so here I've listed 30 responses, R, G, and B, as to what red, green, or blue, for what your preferred color is out of those three. Now, if you look at this, and if I just asked you what was the most popular color, well, looking at this, can anybody tell me which one's the most popular just by looking? Okay. Some would say red. Some would say blue. It kind of depends on where you focus your eyes. The human brain, it's a psychological thing, and there's a lot of psychology in statistics. The human brain can only process, in memory and visualization, about 7 to 13 things at once. That's actually one of the reasons why phone numbers were originally 7 digits without the area code, is human memory. But when you're looking at this, it depends where you look. If you're looking over here, if I'm focusing over there and seeing those 10 things, what appears to be the most popular color? Blue sure seems to me. But if I'm over here somewhere and focusing, well, over there it definitely seems to be red. So it depends, and I don't see any spot in here that would maybe draw me to believe green, but you can tell, depending on where you look, your mind is going to latch on, and you can't focus on the whole thing at once. It just doesn't work that way. If you tried to focus on them all at once, a lot of times what happens is there are certain shapes that are more attractive to the eye or to the brain, depending on how you want to put it, than others. Maybe the letter R is more attractive to your brain than others. So you're going to look at this and you're going to tend to just see the R's. if you try to see the whole big picture. And it's really weird how the brain works. But what you're seeing is most likely not a totally accurate picture of how much is there. So, pardon me, we would want to organize these. So I could write group or class here, but since I know that those groups are actually colors, I'm just going to write color here. We got red, blue, and green. Doesn't matter what order I list them in. There's really no order. I always go RBG, RGB, whatever, just because I do color theory, and that's the order they're used in color theory. Now over here, I want to list the frequency. Notice I left a little gap there. In a finished table, I would never have this in there, but while I'm working with a table, I usually add a column for tallies. So what I'm actually doing there is simply looking up at my list. There's a red, put a tally there. Green, tally for green. Blue and blue, tally, tally. Red, green, blue, red, red, green, red, red, green, blue, red. Maybe I need to move my line. Green, blue, blue, green, blue, blue, red, green, blue, red, 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 blue, red, green. So for some people it is. For some people though, if you try to cross off the R's as you go or something like that, you end up missing them. So it all depends on how your brain works. It's a good point. Some people find it easier to go through and count the R's, count the B's, count the G's. But, you know, I said it all depends on what works best for you. I'm not going to tell you have to do it one way or another. In fact, now when I do my finished table, I'm going to erase those tallies because I don't want them in there anyway. They're not really part of the finished product. It's just something I'm working with. But I do know now that there are 12 red, 10 blue, and 8 green. And I can double check. I knew there was 30 in the list. It adds up to 30. So at least I know I didn't miss any once I did that total. And if you were just counting the R's and the B's and the G's, you'd want to do the same thing. Make sure your total adds up. So now this part really isn't here anymore. And there I have my frequency table. And this is what I would have used like we did yesterday to make our bar graph or a circle graph or whatever. So that is categorical data. Categorical data is really pretty simple. There's not a lot to do with it. Your classes or your categories here are pretty straightforward. Numerical data. When we're talking about numerical data, there are actually two types of numerical data. There's discrete and continuous. Now, there's all sorts of definitions for discrete and continuous. The technical definitions you'll get, discrete is set numbers with gaps in between them, with specific divisions in between them. Continuous is the whole spectrum of numbers. Technical definition for continuous is no matter how close together two numbers are, you can always find one in between them. That's continuous. Now, I'm going to give you a little bit simpler definition of the two of them because it's what works better for me and it makes more sense to me. Discrete can be counted. Anything that you count is discrete. Continuous is generally measured. Weight, length, stuff like that is continuous. Time is continuous. So there are some that are kind of in a gray area, kind of blend in. Money. This is a tough one. If you're asking, if I did a survey, how much money do you have in your pocket right now?
None.
None? Well, that would be most of us. That's what I am at credit cards. With direct deposit these days, I never have cash in my pocket unless I go to the bank and specifically pull it out for something. Would that be discrete or continuous?
Discrete.
Discrete, why?
Because you never had it.
Well,
It's very few and far in between whenever, you
Well,
have to
but
work for it, it adds up.
you got to remember, it's the amount of money is what we're measuring. It's the result of the question is what the data is. It actually is discrete.
You count money.
Because you count, it's pennies. The smallest unit is a penny. You can't get anything in between there. So it is, I mean, if you're talking about the physical money. Now, if you're talking about the physical money in your pocket, and that's why I specifically said the money in your pocket, because you can't have half a penny in your pocket. I mean, you could, I suppose, if you cut one in half, but you know what I mean.
On open days, they had them.
Yeah, I know, they used to.
Okay, so you can, you're wrong.
Anyway, it's countable. You don't have to measure it or anything like that. Now, if you're talking about bank calculations and stuff like that, that might be considered continuous because, those computers are taking it out to several decimal places or whatever.
I have a question on that. Like gold and silver, though, you measure, you don't count. So that would be...
Well, if you were asked what is the weight of a piece of gold, that is continuous because that is a measurement. You're measuring the weight.
Other than that, it would be...
And the price of a piece of gold, that's a gray area. That's a tough one because the price depends on the weight. And the weight is measured, and the price is calculated off of that measured weight. But personally, because you're still going to round the price to the nearest penny, if you're talking about the weight of the gold, that's continuous. If you're talking about the actual price of the piece of gold, I would say it's discrete.
So it's kind of both.
It depends on exactly what part specifically you're looking at and how you're looking at it.
Not that I have any, but for some reason it
I wish we all had some more, but we don't. I mean, there are some things, it'd be nice to say, and statistics is very different from the rest of math in that way. Most of math is very black and white. It's right or wrong. In statistics, there are some of those gray areas where you have to, it depends on who's interpreting it sometimes. I know you don't like to hear that in a class, but what we do in here is going to be very cut and dried. What you're actually tested on is going to be very cut and dried. So let's start out. Let's get back to organizing data in these tables. Numerical data, let's start out with a discrete variable. Let's say we're going to ask the question, how many cars do you own? The number of cars you own. Okay? So the answer to this is going to be a counting. You're going to count the number of cars. You don't go out and measure the cars or weigh the cars. You count how many cars do you have. That is discrete. So let's say that we had a list of people who are answering this. And I'm just going to make the table. So you might list number of cars. And then frequency. Well, there are some people that might not own a car. There are some that might be 0 cars. And let's say for the data we gathered, it never goes over 4. Now what we'd have is we'd have a list of responses over here. 0, 2, 1, 1, 1, 0, 2, 0. Yeah.
You said how many cars, and I automatically think vehicles as cars, so I said 2. Well, I have 1 truck and 1 car. So the truck I wouldn't be considering a car. Did I mess it up doing that?
No, you've got a good valid point there. That's why in statistics, we talked about sampling being very critical yesterday. How you choose that sample, you don't just go out in the hallway and take the first 20 people you see because that's not a good representative sample. One of the second big issues in statistics is wording the question, especially if you're doing some sort of a survey like this. How do you word that question? A little bit of a side note, but it's a very important one. This question here, perfect. Number of cars. Well, what do I mean by car? Probably should have said number of motor vehicles owned. But then, does that include motorcycles? So you need to be very specific on how you word your questions. And you may have to have an explanation with it. You may, number of cars, how many cars do you own? Include cars, trucks, motorcycles, whatever. Or include cars and trucks, but not motorcycles.
Yeah, but would that be you? Are you and your husband? Or
Again, that would have to be defined. You may have to say how many are registered in your name or your name with somebody else. Or how do you want
But realistically,
and that's where the statistics part is really tough, is making that question so that it is a single interpretation. So that everybody that looks at that question interprets it the same way.
and I was just to say, realistically, life in general is not defined.
It's not.
So it's thrown at you, and you have to choose, and it's not always easy.
Well, and I view statistics as probably the single most applicable branch of mathematics. It's used in business decisions, but in your everyday life, you see it all the time. Every advertisement almost that you see on television for products has some sort of statistics in them. 4 out of 5 dentists recommend, or, you can use 20% less of this. Things like that. Those numbers that are being thrown out are statistics. And there's a ton of them out there. And businesses will use, if they've got a good statistic, yeah, they should use them in their favor to advertise. But again, like you said, the exact meaning of it is very blurry. And what it means to one person may be different than what it means to another person. It's because it is so applicable to everyday life. And everyday life is kind of complicated. I don't care how simple your life is, it is still a complicated thing. Trying to accurately model that is very difficult. And even if you're just trying to pick a very narrow piece of it, trying to accurately probe into that little piece of a life, is very difficult to do. That's why I stick with the manufacturing quality control. That's my biggest area of statistics, because there it's a little bit more cut and dry. You have a standard, and if this part doesn't meet the standard, it's a reject. Your question is very clearly defined there. It's a lot easier. But yeah, statistics is very tough. Now, the other side of it, not just specifying what the question is asking. You're like, here, what is a car? What do I mean by car? What do I mean by do you own it? You and your spouse. Does one of your kids, is it your kid's car, but it's registered in your name because they're not old enough to have it registered in their name or whatever. Outside of that even, you have to be careful for emotional response. I've seen studies where they've done, and purposely so, like schools. Let's say they want to look at raising the tax, the school tax in this area. They send out a survey to people, and the first question on that survey, or the only question on that survey, says, are you willing to pay more taxes in order to have more money available for school lunches? Well, what's the first thing you see when you're reading that question? No. Are you willing to pay more taxes is what that starts out with. And for many people, paying taxes is an emotional thing. It's a hot issue. So that's the first thing they see. Their reaction is going to be, no, I'm not willing to pay more taxes. They may not even read why. They're just, no, I'm not. Or if they do read it, they've already made up their mind before they got to the part about school lunches. Because I'm not willing to pay more taxes, period. But if you word that question of, if it means that our children could eat better in school, would you be willing to pay a few dollars more every year in taxes? Now you can see, same question, or the same point of the question at least, but the wording, by focusing on, first of all, bringing up the school lunches first, and focusing on the positive possibilities of it. Kids going hungry or kids eating better, it brings up that emotion. Oh, of course I want our kids to eat better. Oh, yeah, taxes? Okay, I suppose I can pay it. And notice I didn't even use the word taxes there. I said we're willing to pay a little bit more every year. So, I mean, certain words bring up emotional responses, certain topics. Yeah, and it's still the exact same, the point of the question is the same. But the response I elicit, we talked about it yesterday, sending out surveys and envelopes labeled from the Democratic Party or from the Republican Party. You've made up your mind before you even open the envelope. Or you've made up, you don't open the envelope. You make up your mind by not opening the envelope or whatever. So there's a lot of things like that that can be done to skew. And there's a whole study of psychology within statistics that businesses use to force that. How can, a lot of statistics are done because of government regulations. A government agency that's regulating a company says, in order for you to be licensed to produce and sell your product, you must do a survey or you must do a study to show this. Show that customers want this product, or show that customers understand the risk and they're okay with the they're okay with the risk or whatever if there's something going on there. And I for a while I worked with the Statistical Research Center in Madison, and they got orders all the time from companies that were being required by a government agency to do a survey, to do a study on something before they could be licensed. And then a little side note was attached to those saying, hey, we really need the results to come out this way. Design a study so it comes out this way. And there were a lot of ways you could do that. We worked really hard at it. And one of them was, like I was saying, was wording the questions, bringing up taxes first, or bringing up kids going hungry first.
Going to the right area.
Going to the, yeah. Sometimes it was a matter of choosing the sample correctly, of choosing homes that are near schools, the right age demographic. People in their early 20s tend to, well, now, not always, but early 20s, they don't necessarily have it. They may have kids, but they don't have an established family yet, or the kids are not old enough to be in school yet. They're not worried about the school system yet. For the most part, people over 50s and 60s, their kids are out of school, so they tend to be a little bit less inclined to support schools. So there's that key age group, that 25 to 45 or 25 to 50 age group, that's your sweet spot when you're talking about funding schools. All sorts of things like that, or what demographic is most, if it's a product that they're doing a study on, what demographic is most likely to support this product or use this product. And those are things that we had to know. And sometimes we did a study before we could create the study. We would actually do a survey to figure out, okay, maybe it wasn't known what demographic supports these issues. So we would do a study to figure out what demographic supports that issues and then design. And I know that sounds very crooked, and it is. That's why for me, statistical ethics is a very hot topic. We've only talked about this for a couple classes, so I haven't really preached on it yet. I will. How is that? But you're not doing a representative survey of your sample.
You're sneaky, but you're doing your job, and you're
But
the way you
the purpose of requiring that study was to survey the general population. And you have selected a select group of that general population to do your study on that is not representative of the intended population.
So are you saying it's illegal or just wrong?
It's not necessarily illegal. It's just immoral.
Right.
Or not immoral, unethical, I guess. I don't want to get into immoral, but to me it's unethical. And again, you could argue ethics too from one person to another. But there are a lot of things, and when we get into, on Monday, talking about calculating mean, median, and mode and stuff like that, there are things I've seen done there. Accurate numbers, accurate calculations, but extremely deceiving.
You're getting paid to do a job, you're going to do it.
Well, yeah, you're getting paid for a result, and you're doing it, and unfortunately, the better you are at it, the more chance there is that you're going to cross into those gray areas, because that's what you're getting paid the big money for. One of the other things that was done was called stack surveys. They had a phone survey center. I'm sure you've all got that phone call. Hey, ma'am or sir, can you take a few minutes to do a survey for us? We worked with one of those. Those are fully automated. They are not sitting there with a piece of paper reading that survey to you. There's a computer screen in front of them, and every word they say to you comes off that computer screen.
Not all of them.
Well, the ones we did were, there are some that are a little less formal, but the ones we did, every word came off that computer. A lot of your political surveys are actually, some of the most low-budget surveys out there are political surveys, because they're volunteers.
Well, when you're talking about the crookedness and all the
Yeah.
deceiving stuff, I think of politicians. That's
Sure.
where my mind automatically
Yep.
goes.
And one of the surveys we did was actually a political survey for the Clinton administration, but I won't get into what the topic was. But anyway, and that's actually the one I was talking about. I was starting to talk about here is that one. They call it stack surveys. Everything comes up on that computer screen. Literally, they click a button on the computer screen to dial the next number. The computer selects the next phone number. You okay, Cody? Did you get a drink? Okay.
When you're not usually talking to a person either, it's a recorder.
Well, it's being recorded, but usually, a lot of times it is a person. But anyway.
Phone's mostly gone to recorders, and you just put your phone on this recorder.
Oh, sure. But anyway, you click the button, it automatically selected the next phone number, dialed the call. They had the headset on. When the person answered, it actually came up on the screen. Hello, sir or ma'am. Could you, or miss or Mr., whatever, would you please be able to take this time? And then it actually had a box there or whatever of yes or no. If they answered yes, you click that box and it brought up the next. If they said no, it clicked the box and actually brought up what your recommended response was to. If they say no, well, could you please, because it could benefit this, you sure you wouldn't reconsider, all that. Or if they hung up, then it ended the call, of course, and it started the process over with somebody else. But if they said yes, you click the yes, and then, of course, it did, well, okay, now this is the next thing. This survey is for blah, blah, blah. This is the topics we're going to cover. Are you ready? Then the next first question would pop up. Now, the person reading the survey was usually a student getting paid minimum wage, sometimes work study or whatever. So they didn't know what was going on. All they were trained to was read the computer screen, period, and how to enter and click and whatever. So they would read 3 or 4 questions. And like the one I was talking about was for the Clinton administration. The first 3 or 4 questions were very general political questions to decide whether you were Democratic or Republican or liberal or conservative, however you want to word it. And at the end of the first 3 or 4 questions, the computer was programmed to make that determination. If this person, and since we were working for the Clinton administration, which was more liberal, if the first few questions came across as conservative, the computer cut off the survey. Said, well, thank you for your time. Have a great evening. If they came across as what they wanted them to be, a more liberal side, where it seemed like it was, basically, if it seemed like from their answer to the first few questions that they might support the topics that they really wanted to ask about, then they continued with the survey.
Well, that's real crooked.
That's extremely crooked.
Yeah.
Yeah, that's extremely crooked. It's
That
hand-picked.
illegal in some way.
It is not illegal.
No.
No. Of course, you advertise a survey on television, you're just going to say, hey, 67% of people that responded to this study said they didn't care about this scandal or didn't care about this topic or whatever. Anything that is done like that has to have documents to support it. And in those supporting documents, it does say in there somehow how that survey was selected. But who is going to sit down and read through that? And even if you do sit down and read through that, who's going to blast it out to the general public? And who in the general public is really going to understand? I mean, it's kind of that. I mean, that gets done all the time, and it is disclosed in those backing documents. It's just who's ever going to know about it? Medical studies all the time, medical research, drug research. Let's say that there are 200 people that are being tested for a new treatment for a certain illness. There will be, out of that 200, there will be 30 or 40 of them that are actually thrown out of the study before it's done. Now, a lot of people think that's crooked. But what that is let's say you're doing a study on a cancer treatment, and you have this patient dies, but they die of a heart attack. Completely non-related to the cancer. Well, they're thrown out of the study because their death does not affect the effectiveness of the drug you were using to treat the cancer. Unless, then let's say 40 out of the 200 people die of heart attacks. Well, now then you have to go back and figure out, did that drug increase the chances of having a heart attack? So, obviously if they die in a car accident, then they can be thrown out safely, but there may be, again, factors. This is why statistics get so complicated and convoluted, is maybe the drug caused drowsiness.
Kind of like that one with vaccines, when vaccinations causing autism.
Yep.
Remember that statistics that they did? And then later they proved that how he used, what was it? He said that, oh man, how did that go? He said that out of 10, so many kids, let's say there was 10 kids that got the vaccination. Well, 4 of them already had autism. them.
Yep.
And then, so many of them, how did that go? I don't know, it was proven, but the statistics were just totally wrong.
He selected a sample that proved his point, is what he did, basically.
Yeah, but then it was blown out.
Yep.
Because some of them already had autism, some of them,
Some of them already had the symptoms, but just hadn't been diagnosed yet.
yeah, and
Yep.
but he was trying to say that vaccination caused that, so he ended up losing his medical license out of it because he published
Yeah,
it.
as well he should
So
have.
many people, believed this and started not getting vaccinations for their kids.
I never really.
Well, but there's a lot of stuff done like that where people, and they truly believe the point, and that's where it's tough in medical studies. It's not that they're setting out to try to deceive, but when you truly believe something,
Yeah.
it's really tough not to subconsciously do things that affect the results. Subconsciously select a sample in a certain way, or word a question in a certain way. Or let's say I have again, let's go back to cancer. Let's say we've got patients that have a certain type of cancer, and we're testing a new drug against the old drug. And I truly believe that my new drug is better. So I have the two groups. Let's see, I got 50 people in each group. And I'm going to go to the first group and give them the old drug. And I'm going to go to the new group and give them the new drug, which I believe is so much better. Even though I am trying to be totally unbiased, there's a very good chance that my interactions with one group is going to be different than the other. My interactions with the group getting the old drug, I'm going to be, oh man, you guys aren't going to make it. I'm not trying to be that way, but there's something in me that's, oh, you poor things. Where the other group, it's like, yeah, you're getting this new drug. I'm excited. I know you guys are going to get better. And again, I'm not trying to portray that, but there's something inside me that's, just treating them just a little bit different because of that. And there is a huge, some people believe it, some people don't, but it's been statistically proven. There is a huge psychological factor in recovery from many medical conditions. If as a patient you do not believe you're going to recover, your chances of recovery are much, much lower. If as a patient you truly believe you're going to recover, there's been a lot of statistics done that show your recovery rate is much higher. It's your own spirits and your own mental condition has a lot to do with your recovery. So subconsciously, I may be doing things that affect your mental condition that cause you to recover less or better based on that. So that's why in many medical, and also, there's two things. It's called a blind study. First of all, we would never tell the patients which drug they are getting, which of itself brings up a lot of ethical issues. I'm giving these patients a drug that I know works and these patients a drug that I don't think is going to work. What's the ethics there? But they have to go through all sorts of stuff before they sign on to the study to agree, that they know there's that possibility. But so there's a huge ethical issue there that I'm not going to get into because that's more of a regulatory issue than anything else. But then, making sure they cannot know what drug they're getting. But that's called a blind study. So the patient doesn't know what they're getting, doesn't know what category they're in. But there's something called a double-blind study, where the people interacting with the patients do not know which one they're getting. So what might happen is if I'm going to do this medical study, I might hire you, Tammy, to be the one that gives the drugs to the patients. And what I'm going to do is I'm going to put the drugs for these patients are going to go in red cups. Or you got to be careful because colors can introduce emotional responses too. You got to be careful. And it's been found that certain colors in your hospital room can speed up your healing rate. So the drugs go in cups with an X on it. And the drugs for this group go in cups with a Y on it. You have no idea what X and Y mean. I do, but you don't. You just go give them to the patients. So there's absolutely no way that you can have any sort of different mood from, based on the drugs at least, from one group of patients to the other. So they're not getting anything from you that might clue them in as to what's going on.
Unless she mistakenly messed up and accidentally gives you why.
Well, you got to hope that those types of mistakes don't happen. Yeah, you think Tammy would make a mistake like that? Come on.
No.
No. So there are a lot of psychological factors in statistics, is basically what I'm saying. A lot of things outside of what you would get. And I know I rambled on a bit there, but it is very important that you do that. It's just as important as being able to organize the data as that you gather accurate data in the first place. So anyway, This would be just like our colors up there. We would have a list of numbers over here, and we just go through and select them, just like we do with the colors. You'd count how many zeros and how many ones or whatever. So let's say in our study here we had 12 people that did not have a car, 43 people that had one car, 37 that had two cars. What's that put me at? 80? 92? 5 that had 3 cars and 3 that had 4 cars. So there's my frequency table. Now when we're talking about frequency, now I know this one I didn't really do anything different than I did with the categorical table up there. Because it really isn't that much different, because when it's discrete, you have basically your numbers are categories pretty much, even though it's still numerical. But I could have done this with the categorical table up above. I very easily have added a column over here and done this. I'm going to do it with this one just because it's a little more interesting. Some frequency tables, rather than be listed, this is what we would call the raw frequency. It's just called a frequency table, but the technical term is raw frequency. Sometimes, rather than looking at the raw frequency, we look at something called percent frequency or relative frequency. So the word relative and percent would mean the same thing. Some textbooks divide it up and say relative frequency is the decimal version of a percent. So 32% would be 0.32. It really doesn't matter. The first step in finding relative frequency is, just like with our circle graphs yesterday, is to find the total. If we add these all up, what do we get? Hopefully we get 100, because that's what I was shooting for, right? And we do. It looks like we do have a total of 100 there. You got 99? I think you missed some. Yeah. So our relative frequency, we would have 12 out of 100 equals blank out of 100. Well, that's a pretty easy calculation, right? That's 12%. Or 0.12 if you want to write it as a decimal. 43 out of 100 is, of course, 43%. 37 out of 100 is 37%. You can see why I used 100 as my total now, right? Makes my percent calculation pretty easy. If I were doing it up here, this was out of 30. So my percent frequency, or relative frequency, however I want to put it, this would be 12 out of 30 is blank out of 100. Cross multiply and divide, I'd get 40%. 10 out of 30 equals blank out of 100. Cross multiply and divide, I would get 33.33%. 8 out of 30 equals blank out of 100. Cross multiply and divide, I would get 26.67%. Now it's up to you where you round to the nearest percent or nearest tenth or hundredth of a percent. I went to 100th of a percent here just because when I'm dealing with thirds, that's kind of what I'm used to doing, but it might be specified different in a problem. These percents, of course, should add up to 100, but because of round off here, you might get 99.9 or 100.1 or something like that. It has to be very close to 100. If you're getting like 103%, something's probably off a little bit. So that is discrete numerical data. A little bit trickier is something with the continuous numerical data. Continuous data, so like your height. Now we're going to go to the nearest inch, which some might say that makes it discrete because you can count inches, but it's still measurable. So we're gonna use it as continuous even though we're rounding the nearest inch, just because I don't want to have a bunch of decimals in here. So let's make a list here of heights. Again, we're not going to put in yours. I'm just going to make a random list. So there's a list of heights, of just measurements from 20 people. You'll notice here there's not too many of those that are repeated more than a couple of times, 2-3 times maybe. So I really don't want to list out every height from 62 to 73, I think is the tallest one on there. I don't want to have to list all those out. That would be a lot of different categories in my frequency table. So what I'm going to do is I'm going to use ranges. These ranges are generally called classes. I'm going to divide it into classes. Now my smallest number up here is 62. That's called the minimum. The largest number, which is called the maximum, looks like 73. So the range, I know we haven't talked about spread yet, but I'm going to talk about something called the range right now. The range is 73 minus 62, or 11. I'm going to add 1 to that. Always add 1 to the range. So it's 12. The reason for doing that, you find the range and you add 1 so that when you divide it up, you know you're going to have enough classes. So the range here plus 1 is 12. So that's a very important step. Make sure you add that 1 to it there. So at a range of 11, add 1 makes 12. And let's say I want to divide this up into 4 classes. So 12 divided by 4 would be 3. So each class has to have a range of 3. So the smallest number being 62, this first class is going to start at 62. Is it going to go to 65? Say no. No. The range of 3 means the next class starts at 65. So since we're rounding to the nearest inch, that means this class can end at 64. So this would be 68, 71. This would be 67, 70, and 73. Now we double check. Do we include the whole range? Well, we go from 62 to 73. Does that include the whole range of data? Yes, it does. Now here again, we could add that column and do tallies, like we talked about before. And then put the frequency out here. With data like this, a lot of times the tally is simpler to do, because trying to count in ranges is really tough. For the sake of speed here right now, I'm going to do that. We got 62, 71, 68, 64, 70, 73, 71, 68, 71, 72. Oops, did I put the 71 in the wrong spot? I did put the 71 in the wrong spot, didn't I? I already screwed up, didn't I?
Yeah.
Well, let's go back and do it the other way. I'll let you guys count in your seats and I'll count you. I'm going to count 62 to 64. I'm just going to cross these off as I go. Come on. There you go. We got 1, 2, 3, and that's it. 65 to 67. 1, 2, 3, 4. 68 to 70. 1, 2, 3, 4, 5, 6. And then 71 to 73. 1, 2, 3, 4, 5, 6, 7. And that does add up to 20, so I'm pretty sure I got it right. And I could do a percent frequency and stuff like that there as well. This, by the way, we talked about a histogram yesterday. This is the type of data that would go in a histogram. So that histogram would look like this. And you number just like we did yesterday. Number up the side. 1, 2, 3, 4, 5. Pretend that line is straight. 1, 2, 3. 62 to 63 would go up to 3. So you look something like this. 65 to 67 goes up to 4. 68, 70 goes up to 6. And then up to 7. Like that. Notice the bars touch. Because it's continuous data, it means it blends from one category, from one group to the next. The bars touch. That's pretty much enough for today. Any questions? What we covered today isn't really in the homework. It's just kind of extra stuff that leads into what we're going to talk about on Monday. But it's great background information. And to me, to understand statistics, more important than the calculations is really understanding the process. And I don't expect you guys to walk out of here after having only 3 or 4 days of statistics lecture being able to go out and do statistics. But what I am hoping is that when you see stuff on television or in the newspaper or whatever, from some of our discussions, you can at least look at it and ask questions. How was that gathered? What type of sample did they have? You know, how did they word their questions?